Everyone, thank you for joining. I'm on day 9 at JIT. So this is one of the first things that I got to jump into and build. On the LLM side, my experience is all over the place. I've built both our security policies and procedures for generative AI adoption at my previous organization, Clumio, if you're familiar with it. It was just acquired a couple months ago. And then I've also built some small generative AI applications locally. Like I built one to answer security questionnaires and help automate some of my answering security questionnaires from my local database on my machine. So a lot of experience actually building and coding these things. I am by no means a coder. I really am a hacker, which means I understand enough about code to get myself in trouble. If you guys are deep coders, you might find some of the code examples. It's mostly pseudocode. It's not totally functional in here. Basic, but the idea is to kind of be able to speak to everyone who might not be familiar with all the practices in building LLM applications. Quick agenda if you guys want to know what we'll go through here. We'll talk a little bit about who I am, talk about the OWASP top 10 for LLMs, and then I'm actually going to get into some really specifics on how you would apply the top 10 OWASP for LLMs to what you might be building in your businesses. So I picked a couple very basic patterns for how LLMs are deployed in most enterprises, and we'll talk through that. And we'll talk about how to protect those and some Q&A if we have time. Who am I? I'm a security and privacy nerd, really a lifelong runner. I am now the CISO at JIT. I'll give a quick story just on my background and kind of who I am. When I started getting into security before security was cybersecurity. I was kind of like a punk in high school with a laptop, right? And so I used to just like break video games. And there used to be this game called America's Army. And we used to hack that game and kind of mess around with players and everything. My first job I got as a SOC for the CIS Center for Net Security. You might be familiar with CIS benchmarks. I was working for the multi-state SOC there. And first day on the job, I was like talking to someone. And they're like, oh yeah, I used to play a lot of America's Army. Don't know how it came up. The guy goes, I was the server admin for that. I was like, oh, I used to like mess around. That's kind of how I got into technology and learning this stuff. He goes, yeah, I banned you from all the servers. So that was my first job actually officially in cybersecurity. I ran into the guy who was banning me. So LLM threats, I think, are a little bit hypothetical right now, counterpoint to what I put on this slide, but at the same time, they're not. We do see research coming out exposing some of the applications that have been released, some of the libraries that exist from a development perspective. I'll talk about 4 use cases. One, I'll actually show sort of how it occurred and how you might be able to prevent against it. It's pretty fundamental. So there was a popular Gen AI library that didn't sanitize input, which led to arbitrary code execution. Pretty straightforward example, probably not that different than building any other application, right, where you have to sanitize input. We'll talk about that. Samsung actually lost trade secrets to ChatGPT. This one's a little easier to prevent against, and it's less on the code side, but the same principles apply to building applications. They had users that were entering trade secrets into a generative AI application. In this case, it happened to be ChatGPT. That data was shared back for fundamental model development. That information then could be accessed by anyone who knew what to prompt ChatGPT for. There's been a bunch of Microsoft research on Copilot and how to use Copilot in the enterprise, which has led to information leakage. Different things, some of them are kind of hypothetical on if you did these series of steps, hypothetically you would lose data. But there's been a few patterns where you actually can misconfigure it, or at least out of the box, it is weak. And it allows someone to essentially allow the Copilot service to have excessive agency, we'll talk about that, and access data that a user shouldn't have access to. Lastly, I recommend reading this. They published just this last week. OpenAI has Influence in Cyber Operations, an update detailing attackers utilizing LLMs. This is a really interesting read. It doesn't fully apply to the top 10, but you should read it if you're building applications, because it talks about how attackers are utilizing the information in LLMs to carry out information warfare campaigns, specifically on elections throughout the world. So really briefly, there is a top 10 for LLMs by OWASP now. It's relatively new as far as top 10 goes. At JIT, we actually are participating pretty heavily in the development of top 10 for these. Our co-founder at JIT, David, is the maintainer and co-chair for the serverless top 10 OWASP. So it's pretty important for us to give back to the community. So be able to come up here and speak just so early in my JIT career on this was pretty exciting for what we're trying to do, at least to me. A lot of these that you see, I'll go into depth on 3 of these, might not be that different from what you're used to in building applications standardly. At the end of the day, we want to make sure the inputs that we give to an application don't lead to arbitrary results. Sometimes that's code execution, sometimes that may be data leakage. In the LLM world, we often call that prompt injection. And that really means I'm sending something into the model, and I'm trying to find a series of characters or commands that might lead to data leakage or exploitation of that model or the application built on that model. I'll talk more about that. There's things like training data poisoning. That one's very fundamental as well, that the data you're using to build a large language model, you have to be very careful with what you're putting in there. Otherwise, it could result in data leakage, and I'll talk a little bit about that as well. I'm not going to go through all of these in depth. I recommend just going and taking a quick look at the page on these. So let me step back for a minute. I'm going to talk a little bit about building an LLM application. I think it's important to understand some of the fundamentals here. Some of you, this might be very basic, and you go, yeah, of course, this is how you would build some of these. But for some folks, it might be completely new. The patterns for building applications for most businesses actually aren't that different than what you're probably used to building. You have some sort of front end, whether that's mobile app or a web page. You have some sort of core middleware code that you might have. That's typically actually going to interact with the LLM directly. And then in most businesses, you'll see a technique called retrieval augmented generation, or RAG. RAG is basically saying, how can I take my enterprise knowledge or maybe my data or something I want to be able to access through a chat interface or through a large language model and provide that context back so I get accurate results about something specific in a knowledge domain. What RAG actually does is take all of that knowledge and mathematically model it in a way that an LLM can understand. So you're taking human readable text and creating a mathematical model for the context of what that is. And then when you put input in, you can use essentially mathematics to match up and say, this is the direct language or the direct knowledge I need, and pull that directly from your documentation, for instance. So that typically would be in the source data down here. You have a code for what's called creating embeddings. That really means just mathematically modeling human language. That's the simplest way to put it. You store that in something called a vector store. Vector stores are all sorts of things. There are specific databases, vector databases like Pinecone you may have heard about in the news. But you can also use pretty generic SQL for doing vector embedding storage. You can use a text file. I built applications that way, basically locally, to do some embeddings and then store them in a text file and read them into a large language model. Is there any questions here that I can answer before we go forward? If you guys have some, I'm happy to. All right, moving right along. So let's talk about prompt injection a little more deeply. Prompt injection, again, I'll just recap on it. This is when an attacker may design some sort of input that's going to cause an output that the designer didn't intend to occur within an LLM-based application. You see online people talking about prompt injection and maybe hacking ChatGPT, or maybe there was some of the other fundamental models and companies that are out there building large language platforms. They're really focused on using prompt injection to try to get the model to disclose training data that might be in it that shouldn't be disclosed. So you'll see that as a method of prompt injection. But prompt injection can do other things. So if you're using agents or essentially using language to understand what something should do and then carry out an activity on behalf of the user, you might actually be able to use prompt injection to manipulate that to do something excessive. Sometimes that's excessive agency, sometimes it's prompt injection. I won't get into too much of the differentiation, just the fundamentals here behind it. So this is one of the ones that actually did occur in the wild. So this is something we've seen occur in libraries. There's a very popular library called LangChain. LangChain kind of allows you to build agents in large language model applications. What it really does is allow you to kind of chain together a bunch of language-based commands. So you could say, if this type of thing happens, I want to do this. And if the human says this, and the model interprets it X way, I want to carry out these activities. And again, oversimplifying a little bit, it's one of the most popular libraries. The NVIDIA Red team actually discovered a vulnerability in LangChain that was very fundamentally allowed any Python code to be executed. So if you built an application on it and were using it, you could then have a user pass in Python code and have it executed on the machines that this was running. Relatively large deal if you're building big applications. So this would be a code example here on what that would look like. This is very fundamental. I'll explain it. You don't have to read every word up here. Essentially, you have a function in which you may want to pass the query from the user. So you have some input that you're going to pass to the LLM. In this case, in a RAG application, you need to read knowledge into that. And you may read those vector stores. And this is a very kind of silly example, but it can happen at a larger scale, where I had the psopen command to open and read my vectors from a text file. So in this case, psopen allows you to actually, or popen rather, sorry, popen allows you to use any command on a typically Linux machine through Python and execute those commands. So if I, in this case, use a query, which you can see down here, and terminate the command with a semicolon, I could then execute any arbitrary binary on a Linux machine with the way this is set up in this type of code. So this would be one way that you could get prompt injection by taking that user's input from the LLM. When I pass it to that function to retrieve the knowledge that I'm trying to get, that I want my LLM to be able to answer, I could pass arbitrary commands that could execute actually locally on that Linux box and have the permissions of the user that's running. The way to fix this, so this would be running typically in your application core code, right? Where the input goes from the user, goes into that code that you're using to interact with the LLM. That gets passed to the LLM model. We really want to do sanitation. I think most people that if you're building applications, you're familiar with the idea of sanitation for SQL, right? Or other types of variable input where you're trying to pull data out. This is almost no different. There's a few differences in the patterns and the type of things you're looking for. And if you're building a fundamental LLM at OpenAI or something, sanitation becomes a much bigger deal and it's much more complex. But for RAG applications, it's kind of straightforward. In this case, in this very, very simple example, we can just filter with a regex and look for certain inputs that we don't want, right? So that would be one way to prevent and actually implement filtering and input sanitization to prevent against LLM-01. If you're building an application that's a little more robust, there's also open source libraries out there that you can use. Rebuff AI is one of them. I haven't used it a ton, so I'm not saying it's a great library or it's bad, but actually I like the content, their methodology, and the way they're structuring it. And they'll use heuristics to filter out potentially malicious input. Again, same thing if you were building something with SQL. Same patterns apply here. You could use this library to figure out if you have this type of attack occurring. Again, let's go back to the SQL injection type thing. If you're used to that, input parameterization is one of the core ways that we build SQL within our applications or SQL queries in a way that's more secure. Almost everything from any type of retrieval, whether that's SQL or other languages, typically you're going to parameterize that, and that prevents injection often. Same thing applies to Python. So you can do the same thing on that front. Switch over to LLM-06. So skip around here just so I can get through a couple examples. 10 would be a lot in one talk. Sensitive information disclosure. This is probably the most common one talked about. This is what CISOs often care about most is, isn't my intellectual property properly secured? Is there a methodology for the AI applications I'm building or the LLM applications I'm building? Is there a risk that information that I have in my company could get out to the wild? Maybe that's if you're doing government contracts. Maybe that's something on the government side that you don't want to leak. Maybe it's just my intellectual property like Samsung. Or maybe it's something more. Maybe it's my source code that I'm building for an application. If that gets leaked, someone might be able to exploit it or go and take my market from me by building that own application. So in this case, let's use healthcare as an example to walk through this. Let's say you want to have some sort of healthcare support agents internally be able to access the health records or something and to be able to give customers more information contextually on a phone call quicker. If you're to set up an LLM with that and you don't put the right controls in place, maybe agents could access excessive information through the querying of that data that they shouldn't be able to access. Maybe certain patient data should be obscured. Or maybe if you're training what we would call fine-tuning, a fundamental model where you're tuning a model with certain data and you want to use your healthcare data to do it, if you don't sanitize that data, you don't change the way that data is being utilized, that can be baked into the model and then disclosed. So that happens often. You can see here the definition if you want to read it. Here's another really quick example on this side. Again, when we're thinking about this mentality of using RAG or retrieval augmented generation and pulling vectorized tokens into your application to give knowledge and using the healthcare example, this would be a method where when we retrieve the documents, we don't do any filtering whatsoever. So it can access any knowledge that I have in my vectorized files. So this is one way that that information may be disclosed. And you can see here the query prompt that we have in this example code is one of the company's secret projects. And that would get passed in, and since it has excessive access to any information, it might say secret project, and find that secret project document and return that information. One of the best ways to prevent against this type of attack is to filter the source data that you're training or vectorizing, in the case of RAG, before it even gets put into your vector storage. So filtering data can be done a bunch of different ways. Most people are doing it programmatically. So before you run the code to create the embeddings or the mathematical models behind this data, essentially, that you're using, you can programmatically filter that out and say, if any of these things are present, don't include this data and don't embed in it. A lot of larger projects require some sort of human interaction to build and maintain these data sets. So that's part of it as well. If the humans actually can go through, decide what files should be included, what information, you can only select information that's going to be put into the vector store in this case. So this could be human, this could be code. There's a bunch of different ways to implement these controls. Again, really simple code example. If I see any of these sensitive keywords, confidential, secret, if you're doing data classification, you see any of those in the documents, don't embed those into the vector store. Very simple filtering method. There's more complex ones as well, which we're happy to talk about if you want. Second, you might want to implement access control. Fundamental, right? That's one of the things that we do across every domain in security is, do the right people have access to the right things, and do they not have access to what they shouldn't? Same thing in a application built on AI. If you're putting an LLM in front of something, make sure that you're using the right service accounts that are restricted down to the permissions that you want if you're querying something directly. You can query SQL databases and other things directly from LLM apps. Using the right access controls in those methods and not giving overly permissive service accounts will help prevent against these types of attacks where you're leaking sensitive data. And then there's a ton of tools out there, open source libraries to do anonymization of data. Let's use the healthcare example again. This is a really common one. You want to be able to have domain-specific healthcare knowledge in your LLM app. That's pretty much an area you always want to do anonymization. You don't want to train on the actual data set. And there's ways of doing that, methodologies that are out there. So I'm going to talk about one more that we see actually in the wild, excessive agency. Excessive agency is this mentality where you can allow LLMs to carry out tasks on behalf of a user. So we see some of this coming up in the ideas of like agent-based AI applications, and a lot of discussion about the future of AI is agent-based. My personal opinion, a lot of it's not there yet, and it's not quite mature enough for most areas, but there's very simple things we can do. Like I'll show an example here where maybe you want a LLM app to be able to send emails on your behalf. That's pretty straightforward. We can build controls to do that. You might be able to have your sales team, for instance, say, from my CRM, I want to send emails to these 5 contacts. And then the LLM app actually can go and execute that and use an agent to carry that out, right? A large language model is only generating novel text. That's all it's doing. It can't go and send emails itself. You can't just import a model and it's going to be able to go and run the internet. So if we wanted that type of application, we typically would add something into this architecture where we'd have some logic for an agent trigger. If I see these conditions take place or these types of text, the LLM may provide a response back that you actually catch in the code and trigger an agent. And that agent typically would reach out to an API to do whatever it might do. So if I have again, using that example where I might want to send emails. In this case, I have a function that would connect to something, send a meeting invite out. Again, pseudocode is not exactly right. I don't have any checks on this. There's no human in the loop. As soon as you say, go and do this thing, LLM, it'll just go and start sending emails out. That's what we would describe as excessive agency, right? It has the ability to do things that you don't actually control the output of that model or that tool. A very simple example of being able to fix this is do the human in the loop methodology. And you'll see a lot of talks about this. I went to a talk probably about 6 months ago now. And I think I had the innovation officer from BlackRock and some of these other people on the panel, some of probably the most creative and smartest people building LLM-based applications at some of the largest financial institutions. And they said all the value they've been able to drive out of this has been human in the loop. So I think not only is this a great security control, it's actually driving value in the applications and making it a lot more useful. So in this case, very simple, just wrap this in an if statement. Ask the user, is this the right activity you want me to carry out? And if you hard code that in with the logic, you're not going to allow the LLM to do things excessively. So I'm going to wrap this up. Quick summary, many of the common weaknesses that you'll see in LLM apps, especially in the OWASP top 10, are pretty prevalent across all domains, right? It's the same type of, do I have the right input? Am I sanitizing inputs? Is the input that a user provides actually going to get the outcome I want? Or are they going to be able to manipulate the system to provide some sort of output that benefits them, right? That's the entire idea behind hacking, right? Can I manipulate the system to do something on my behalf that it's not intended to do? That applies here in building LLM applications. It's nothing that most people, I think, aren't used to building. It's the same mentality, right? It's that old joke of a QA tester goes into a bar, orders 1 beer, 10 beers, AZZQL, exclamation point beers. Same principle here, right? Many of the common weaknesses are related, and they can, OWASP, like the information disclosure versus prompt injection, those are very, very closely related, right? So if you have one vulnerability, you might actually have multiple weaknesses within that. The answer is the same thing. We need to do code validation. We need to make sure we're doing static analysis. You need to make sure that you're parameterizing things correctly. You need to make sure that your access controls and your permissions are going to be properly implemented for these applications. I'm saying all that to say, just because it's a new domain, really, in the computing world, the same knowledge that you bring to the table today and the same things that you're used to implementing process-wise are going to apply to building these. And don't be afraid of the new domain and the new world and all the new acronyms and language. You'll still be able to carry out the same application security programs that you have been, just with a slightly different lens, and we put some new language on it, right? LLMs provide great power. They really are really cool tools. There's been a couple instances in my career where I've been like, wow, that's a really different way of thinking about things. I think LLMs are one of those. There is a lot of snake oil out there in building these, but we can build awesome applications that make it easier for our end users. We just have to build them securely. And of course, with the great power of new applications comes great responsibility. Thank you for your time. If you guys have any questions, I'm happy to hang out here, answer some questions, tell you a little bit about JIT and what we do, or just spend some time with you guys. Thanks for coming to the talk.
We've got plenty of time, so if you want to talk about any of these LLM vulnerabilities in greater detail or ask something else, now's the time. Yep, go right ahead.
So you talked about filtering the inputs and outputs. So what if, say, there is a key and someone did prompt engineering to get that API key, but they are getting the output in binary. So how do you involve filters that check for everything in, say, other encodings too? Because that the scope is used for that.
Yeah, I mean, I think that when you're implementing those things, they're just a bunch of conditions that we'll have to learn over time for some of it. And that's a great example of using maybe a third-party library like the one I mentioned, where they're building heuristics into looking at what's occurring. So they're looking at the patterns of behavior, not necessarily the direct string input and doing string-based filtering. Those are the two that come to mind. I'd have to spend some time really thinking about it to give you a really proper answer on the best way to go and prevent those, but that's what comes to mind immediately.
Can you just look at the mic?
Is there any way for us to get the slides with those code examples and like the CP numbers on them?
Oh, yeah. Is there a way through LASCON to publish the slides?
So we leave it up to the speaker to provide a link. But as a fail-safe, sometime after the conference, LASCON does put all the videos of these speeches up. So if you don't see the standard way, I'm sorry, I don't know the standard. If you don't see like the speaker offering it, usually you can reconstruct the info from the videos that get published.
If you come up after, I'll send it to you right now, but then I'll also try to publish a way to everyone can access it easily.
Thank you.
Yeah.
Great. More questions?
Yeah.
One moment, let me give the mic.
A lot of these you mentioned kind of remind me of the, like you were mentioning, old SQL lessons.
Yeah,
right?
yeah.
You know, restricting strings and things like that. But it seems like a lot of these are, you know, you just give the agent, say, hey, look at all my SharePoint documents that we've had forever.
Access control, right.
Nothing has been properly tagged, you know, this is PII or anything like that. So, you know, what do you see that as part of, you know, is that going to be like all these old lessons from SQL days are coming
I think
to
so.
fruition again?
Yeah.
You know, because basically it's like you just have given, you know, read access to all.
Right.
And said, hey, query whatever you want. It's cool.
No, I completely agree. It's one of the fundamental reasons I think there's not more fundamental model companies, right? There's only a few. A fundamental model is the OpenAI model, the Llama model, right? Things that are these massive models that take a lot of compute to build them, but not only does it take a lot of compute, people will pay for compute. There's plenty of people with money that will go and buy, but curating the data that leads to something successful that also doesn't lead to information leakage or any of these other issues that we might have, such as misinformation, et cetera, is the hard part of building these fundamental models. You can go and buy a book right now with all the code you need to build an OpenAI model. Right? The knowledge is all out there. It's really the human work and the legwork and the difficulty and the challenge in organizing those teams and executing it repeatedly that lead to building those. And I think the same thing's true on the enterprise side. I think the same enterprise problems we have in building applications apply here too, right? And a great example that comes to mind for me was in my last organization, being a startup, information was everywhere across the organization. There wasn't great tagging. Some was in Google Drive, some locally. Some people, we had Microsoft 365 subscription too. Some people would put things up there. And while we can control access from a human perspective and identity perspective, when we have these new non-human identity tools that help us understand these access patterns, it's still really tough to say, how do I automate these things? And sometimes it's biting a bullet and just having a human team say, we can scope this information, we have these use cases, let's start small, and then we can build bigger. At least that's my take. I don't think there's a great answer, though. Fundamentally, when you have unorganized information, it's challenging.
Here we go. One sec.
So my question is, the person talking to using NLP to the LLM, does that LLM inherit the permissions of that user? And I'm assuming, somewhat restricted from the human. Does that LLM inherit the human access controls, or is using a carte blanche to have any access, like root level access? More so than that human being talking to it. So can you talk to that a bit more?
Yeah, so I'll share two examples. One thing I've evaluated is some of the enterprise search tools that are meant to solve the problem we were just talking about. Is data's everywhere. It's not solving the problem of which data should I serve. But one of the ways they do solve that is each user has to connect their own data sources and only can query their data sources. And in that case, they do pass the permissions down through the APIs, so that way you're only querying data that you already have enterprise access and permissions to. On the other side, if you're building something that's publicly accessible, you might not have a permission set right, and so in that case, you just have to make sure you're implementing the right service accounts and only accessing data and serving data that's appropriate there. But I have seen that in some applications that are available. Yeah.
More questions?
So I have an interesting question.
Sure.
Recently I came across where I want to train a model, but in order to train a model, I have to provide accurate information to it. Let's assume that I need to provide some from healthcare data or something like that.
Sure.
So in a traditional web application, right, I can obfuscate that information, or I can encrypt the data. That will still work. But in case of AI models, I can't do the same, because then the model will not provide me the actual output which I'm looking for.
Right.
So in those kind of scenarios, like, what is the best approach?
Sure. And again, I'm not an expert on building the applications. I've only done a little bit of hacking around it, so I can give you my best answer. If you're trying to build a model that has domain expertise generally, like a textbook expertise, right? It's not a specific implementation. It's not information about a specific human. Fine-tuning actually is great. So if your organization's develops intellectual property that's unique to that business that's not accessible globally, that's when tuning a model or building a model makes the most sense. If you're trying to provide explicit answers about something that is inherently true, my name is Jacob Berry, right? That's a fact that you want. It's not a piece of textbook knowledge of humans have names, right? So fine-tuning a model so it can say humans have names, these are typical names is one thing. But if you want to say you are Jacob Berry, typically actually RAG's the best way to do that. And the reason for that is when you create the embeddings, you're creating a link actually from the embeddings to the source data. So when you run that query, it then says, okay, it matches these embeddings. I can incorporate that into my response, but I'm actually going to pull the source data directly into my response. I'm not going to generate a novel, unique response on that, more or less, right? I'm adding some fuzziness in there.
But RAG and fine-tuning comes later in the process, right? What I'm talking about is the initial stage itself, where I want to train the model. So in order to train the model, I need to, it's more of a chicken and egg problem, right? I want to make sure that I provide the right amount of data, which is accurate information. If I provide some false information, the model will not provide me the actual data itself.
Yeah, I mean, I'm not an expert on actually building fundamental models, but that goes into actually your weighting and your biasing of different things and how you're building that data is my understanding. But I would talk to someone who's fundamentally building models on the architectural side, because you're not going to get a perfect answer from me on that front at all.
I'm not a builder too, but I came across an interesting scenario where I was doing a review of a service where I came across this problem. And it's a chicken egg problem. I don't want to provide the information. If I provide the information, then I'm violating all the security principles. But if I don't provide that, then I'm not getting the actual input or the actual functionality of the model itself.
Sure, yeah. I mean, it's challenging. It's one thing that comes to mind is that might be like 7 steps back. If you're building a fundamental model, something might have gone off the rails on the architectural decisions, right? Like it's very rare a fundamental model actually makes sense to build as an organization. One, because it's so expensive to run the GPUs, right, and some other things. But yeah, I can't give any better answer than that.
Yeah, it's interesting. It's like you're training your model on secrets, but you're saying, by the way, don't disclose secrets. But here's the billion secrets, yeah. Next question. Okay, I think that's it. We'll call it. Thank you very much, Jacob.
Thank you, everyone.